Here we're looking at direct and inverse variation. So there's two forms. There's the direct form where we have y equals k times x. That's very similar to what we're used to with y equals mx. So the k is going to be the gradient of this function, and as there's no power other than 1, it's going to be a straight line when we graph it. Here we've got y equals k over x. So as this is over x, this is going to resemble something like a hyperbola. So we're going to look out for that one in the second example. The first example, we're looking at that garden mulch is sold in bulk with the cost C, which is proportional to the volume V in V, which is in meters cubed. We have to write this algebraically. So we're going to be using a new symbol, or new to most people. So what this question is saying is that C is proportional to the volume. So C is proportional to the volume. It looks like a bit like a fish. That's the symbol we're going to use for proportion. So if that's the case, then that means that C is equal to KV. Okay, so that's our answer for A. We've written it algebraically. So for B, it asks us two things. It says the shop quotes $270 for 7.5 meters cubed. Find the constant of proportionality and graph the function. Now I've written up here k is a constant of proportionality, so that means that we need to find the value for k. So we're going to input these values. The cost, it's 270. We don't know what k is, and the volume is going to be 7.5. So we'll sub those values in. Now if we divide both sides by 7.5, we're going to have 270 over 7.5 is equal to k. So sub that into a calculator, we get k is equal to 36. So if k is equal to 36, then our equation is going to be c is equal to 36v. Now the other part it says is to graph the function. So when we're graphing the function, we're only really talking about the positives, because you're not going to be spending less money than 0. You're not going to be giving them back money, so we can just graph the positive quadrant of our graph. So if we do that, we're going to have this. This is our x. This is our y values. But in this situation, we're not using x and y. I've just written that so you can kind of have an idea of what we're doing. In this situation, v, that's going to be our x. That's our x. And in this situation here, c, that's our y. So that just putting those x and y values just helps us because it makes it a bit more familiar. So for this graph, we know that it's going to start at the origin, because if it didn't, it wouldn't really make much sense. So let's substitute a value in for v, and we'll see what happens. So if we have v is equal to 0, then c is equal to 0. So of course our first point is going to be 0. Now we could pick other values, but they've already given us one. They've given us 7.5 and 270. So if we graph that, we'll just we haven't set axes yet, haven't set dimensions, so I'm just going to make that 7.5 as our v and 270 as our c, and all we have to do is just connect those dots and we'll have a graph of that function. So that is our c is equal to 36v. So that answers our part B. Part C, that asks for how much does 12 meters cubed cost. So well, we actually know that what this function is now because we've got our value for k, so we can just substitute that value in for v. We'll have c is equal to 36 lots of 12. So of course c is going to be $432 for this situation. Now we can use a similar idea for D. It's going to be the opposite, so we're trying to find our volume. It says how much can I buy for $600. So if we pop in $600 for our C, 36V. To get V by itself, we're going to divide both sides by 36. So that gives us our answer as V is equal to, well, that's going to be equal to 16.67 meters cubed. and that's to 2 decimal places.